Hello tech lovers! This is the second and last part of Mobile Communication Generation series. In this video, I will talk about the evolution of mobile communication since the 4th generation up to the 5th generation. In the previous video, we discussed about the 1G, the 2G, and the 3rd generation. If you haven't seen it, the link for the video is in the description. Watch it because it's great, and let's go! But first, don't forget to hit the like button, subscribe to the channel, and leave your comments below. By doing this, you will be helping the channel to grow, so that I can produce videos with more and more quality. My name is Sheldon Eman and welcome to my channel. As I was saying, 4G is a high-speed data rate plus voice system. There are two 4G systems. The first one is called Universal Mobile Telecommunication Systems, the UMTS. And the second one, UMTS Evolution. UMTS Evolution is commercially accepted as 4G and is called long-term evolution, the famous LTE. And it is composed of a new air interface based on orthogonal frequency division multiple access, OFDM, and a new architecture and core network, the CN, called the System Architecture Evolution, SEA, or Evolved Packet Core, EPC. The United States has developed the WiMAX. WiMAX stands for Worldwide Interoperability for Microwave Access. It's a system using orthogonal frequency division multiplexing, the OFDM, evolving from Wi-Fi. The other is the LTE system that was developed after WiMAX. The technology of LTE and WiMAX are very similar. The bandwidth of both systems is 20 MHz, and the major cellular operators are favorable to LTE, and most countries around the world have already started issuing licenses for 4G using current developed LTE systems. The cost of licensing through auction is very high. Thus, we could say that migrating from 3G to 4G means a shift from a low data rate for internet to high-speed data rates for mobile video. LTE is not backward compatible with UMTS and was developed in anticipation of higher spectrum block allocation than UMTS. During the World Radio Conference in 2007, the standard was also designed to operate with component frequency carriers that are very flexible in arrangement and supports carriers from 1.5 MHz to 20 MHz in width. The LTE standard offered significant improvements in capacity and was designed to transition cellular networks away from circuit switches to functionalities, which provided a major cost in reduction from previous generation. At the end of 2007, the first LTE specification were approved in 3GPP as LTE Release 8. The LTE Release 8 system was a peak data rate of approximately 326 megabits per second, increased spectral efficiency, and significantly shorter latency, down to 20 MHz, than previous systems. Simultaneously, the ITOR was developing the requirements for IMT-ADVANCED, a successor to IMT-2000, and nominally the definition of 4th generation. LTE Release 8 did not comply with IMT-ADVANCED requirements and was initially considered a precursor to 4G technology. Although this statement was subsequently relaxed in common parlance and LTE is uniformly accepted as 4G, 3GPP LTE Release 10 and deployed as WiMAX were technically the first air interface developed to fulfill IMT-ADVANCED requirements. Despite being approved 4G technology, WiMAX had difficulties in gaining widespread acceptance and is being supplanted by LTE. The LTE Release 10 added several technical features, such as higher order MIMO and carrier aggregation, that improve capacity carrier aggregation up to 100 MHz of total bandwidth, and allows an increase of data peak rate to a maximum of 3 gigabits in downlink and 1.5 gigabits in uplink. Higher order MIMO configuration up to 8x8 in downlink and 4x4 in uplink are also involved in the performance improvement. 3GPP standardization of LTE continues and is expected to be proceed to release 13 and beyond. The release 11 refined some of the LTE release 10 capabilities by enhancing carrier aggregation, relaying, and interference cancellation. New frequency bands were added and the use of coordinated multi-point transmission and reception (COMP) was defined. LTE Release 12, which was concluded in March 2015, added several features to improve the support of heterogeneous networks, even higher MIMO, and aggregation between frequency division duplexing, the FDD, and time division duplexing, the TD, carriers. Several features for the offloading of the backhaul and core networks were also defined. Further, in the LTE releases 12 and 13, new solutions known as LTE-M and Narrowband IoT, the NB-IoT, were introduced in order to support massive machine-type communication, the MTC, devices such as sensors and actuators. These solutions provided improvements in terms of extended coverage, longer battery life, and reduced cost. Release 13 also targets extreme broadband data rates using carrier aggregation up to 32 carriers. The cellular global mobile market was about 8 billion subscribers by the end of 2015, where the GSM-H family, including EGP areas for data connectivity, is a dominant radio access network in use. GSM has a global market share of more than 57%, corresponding to 4.26 billion subscribers. It's well beyond peak use and is currently in decline. On the other hand, the number of 3G subscribers, including HSPA, has risen since 2010 to 1.94 billion subscribers, which represents 26% of the market share. The Ericsson Mobility Report projects that WCDMA HSPA subscriptions will peak by 2020 and will decrease past that point. The dominant 4G standard, LTE, is expected to reach 4.1 billion subscriptions by 2021. Hence making it the largest mobile technology. In the exciting era of 5G, new communication requirements pose challenges on existing networks in terms of technology and business models. It will be a system of super high capacity and ultra high speed data, with new design requirements tailored towards energy enlisted systems and reduced operational expenditure for operators. From mobile broadband MBB to extreme MBB. The extreme mobile broadband XMBB services will allow 5G to meet the continuing demand for high data rates and high trafficking demands in years beyond 2020. The widespread increase in video traffic and in interest in virtual reality and ultra high definition video streaming will create demand for data rates of order of many gigabits per second. The introduction of 5G will allow wireless networks to match data rates and use cases that are currently handled by fiber access. The tactile internet will additionally require support or very low delays through the network. This requirement, along with the high user data rates requirements, places even greater demands on peak data rates supported by the system. The next generation of mobile network must meet diversified demands. The International Telecommunication Union (ITU) has classified 5G mobile network services into three categories: enhanced mobile broadband, the EMBB, ultra reliable and low latency communications (URLLC), and Massive Machine Type Communications, the MMTC. The EMBB aims to meet the people's demand for an increasingly digital lifestyle and focuses on services that have high requirements of bandwidth, such as high definition, videos, virtual reality, and augmented reality. On the other hand, the UR LLC aims to meet expectations for the demanding digital industry and focuses on latency-sensitive services, such as assisted automated driving and remote management. By the other hand, the MMTC aims to meet demands for a further developed digital society and focuses on services that include high requirements of connection density, such as smart city and smart agriculture. The expansion of service for mobile network enriches the telecom ecosystem. A number of traditional industries, such as automotive, healthcare, energy, and municipal systems, participate in the construction of this ecosystem. 5G is the beginning of the promotion of digitalization of personal entertainment to a society interconnection. Digitalization creates tremendous opportunities for the mobile communication industry, but poses a strict challenge toward mobile communication technology. In this context, 5G envisages not only to invented technology, but a technology ecosystem of wireless networks, working in synergy to provide a seamless communication medium to the end user. Thus, we can say that moving from 4G to 5G means a shift in design paradigm from a single discipline system to a multi-discipline system. Hey tech lover, thanks for watching and don't forget to like and share the video. Leave your opinion in the comments below. Tell me what you want me to talk about in the next videos. The link for the previous video, the part 1, where I talk about the first, the second, and the third generation is in the description. Watch it cause it's great. Until next time, hey yo.